All right, welcome everybody. Today we're going to go ahead and do the second part of lesson number 43, which was all about developing and using the unit circle. Remember that last class we did the first 2 pages of notes live. I'm going to go ahead and do a quick review of what we learned, and then we're going to go ahead and work through the applications, after which you'll be totally prepared to go back and complete homework number 43. So a reminder of what the unit circle is. It's a circle with a center of 0, 0 and a radius of 1. That's an equation of x squared plus y squared equals 1. Here are the angle measurements of the unit circle, the degrees and the radians. Remember, you essentially need to memorize this or be able to do these conversions quickly and conveniently, preferably without a calculator or without just looking at your notes. Remember that to create the circle, we first went around and counted in 45s. That gave us the yellow and the blue. Then we went around and counted in 30s. That gave us the pink and the purple. That's how we did everything in degrees. Then we converted those 45 and 30 and went around and counted in pi over 4s, in pi over 6s, and then reduced. Remember that every time you reduce, you make a new family. So there's the pi over 6 family, which is here in pink. There's the pi over 4 family, which is here in yellow. The pi over 3 family in purple. And then the pi over 2 family in blue. So again, these are the degrees and radians of the unit circle. On the next page, we took it a step farther and we went ahead and found the ordered pairs of the unit circle. In order to do that, we took the fact that the radius of the unit circle is exactly 1, which means it's its longest when it's at the quadrantals, which is how we got the values of positive 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Then at the bottom of the page, because of the fact that 30, 60, and 90, and then 45, 45, 90 are those special right triangles. We set up those ratios to determine the ordered pairs for the other families. Notice that in quadrant 1, all the ordered pairs are positive, positive, where in quadrant 2, all the ordered pairs are negative, positive. Quadrant 3 is a double negative, and quadrant 4 is a positive negative. I just want to kind of reiterate the fact that the equation for the unit circle is x squared plus y squared equals 1. That means that for any ordered pair on the unit circle, if you square the x and if you square the y and then add them together, you must get 1. That's the whole point. And I promise you, if you were to go back and do just that for every single value on the unit circle, you would in fact find that to be true. So let me just go ahead and get rid of those for future reference. Okay. All right. So now that we've kind of developed those values, let's go back and talk about what it is we can do with them. So we're now on the 3rd page of the notes. Notice that over here on the left-hand side, I have for you again some circle with some radius, which intersects the circle at the point x comma y. We already know sine, cosine, tangent, cosecant, secant, and cotangent in terms of opposite, hypotenuse, and adjacent. Now we are going to redefine them in terms of being on a circle. So if they're on a circle and you look at the picture over here on the left-hand side, if you were going to be doing a sine value, if you were to still think of it as an opposite over hypotenuse, again, this is the x distance, this is 90 degrees, and this is a y distance. If you were to think of a sine as being an opposite over hypotenuse, in terms of a circular definition, it would be the y value over the r value. Write that a little bit neater. So when I ask you to define the trig functions in terms of a circular angle definition, you are from this point forward going to think of a sine as y over r. A cosine is going to be an x over r. And a tangent is going to be a y over x. Remember that the reciprocal relationships still hold. So a sine goes with a cosecant, a cosine with a secant, and a tangent with a cotangent, which means to find those ratios, all I have to do is take the reciprocal, which means a cosecant is going to be an r over y, a secant an r over x, and a cotangent an x over y. So these are the definitions you're going to use when you are on any circle of any radius. So that's probably important that you want to note here. So for this column, this is a circle of any radius. The reason why that's important is because in the final column here, we are going to specifically be talking about a circle that's the unit circle, which means it has to have a radius of 1, which means I'm going to take the definitions from the previous column and I'm going to change all the r's to 1s. So if I change y over r to y over 1, that essentially means that sines are just y values, cosines would be x values, and tangent would continue to be y over x's. If I do the reciprocals, I would get the reciprocal of just y is 1 over y. The reciprocal of x is 1 over x, and the reciprocal of the tangent would be x over y. So these are now going to be our unit circle definitions. So as long as you are on the unit circle, either because I tell you that you are, or because you get any value that's on the unit circle, that's how you know that you're actually going to use the last column in terms of the definitions. So what does that actually mean? What can I actually ask you? Well, take a look at the next set of problems. So using the coordinates of the unit circle, find the exact value of each of the following trig functions. So for each of these problems, there are 2 things to consider. What ratio and what ordered pair. So the sine of 3 pi over 4. If you have your notes from yesterday, you're going to want to keep those in mind. So I have a little reference guide that I'm going to pull up. So the sine of 3 pi over 4. The first thing you're going to realize here is that because 3 pi over 4 is on the unit circle, when they ask you for the sine, they are asking you for the y value of the ordered pair at 3 pi over 4. So if you look at your unit circle and you go to 3 pi over 4, they are simply asking you for the y value. So the y value is the square root of 2 over 2, which means that is going to be your answer. So the square root of 2 over 2 is the sine of 3 pi over 4. And that's it. Each of these values is going to be some ratio based on the definition and the location on the unit circle. Now remember, in the past, you wouldn't have had these in front of you, so this should actually be even simpler because of the fact that you do. For the middle one, the cosine of 3 pi over 4 plus the sine of 7 pi over 4, you have to evaluate each one separately and then simply add them together. So the cosine, if you take a look at your ratios, the cosine is an x value. The sine is a y value. So you are, make sure that's like a y. So 3 pi over 4, we need the x, and 7 pi over 4, we need the y. So if we go back again to our reference here, 3 pi over 4, the x value is negative root 2 over 2. 7 pi over 4, the y value is negative root 2 over 2. So if we go back to filling in our values here, we are going to take negative root 2 over 2 plus negative root 2 over 2. That's going to be negative 2 root 2 over 2, which simplifies to be negative radical 2. So for each of these problems, this is all it's asking you to do. Find the appropriate ratio and find the appropriate value on the unit circle. So let's try a couple more. So the tangent of pi over 6. Remember that because you're on the unit circle, a tangent is a y value over an x value. So if I go back to my pi over 6, I'm going to have to put whatever that y value is over whatever that x value is. So I'm going to have to put 1/2 over root 3 over 2. Remember, when you're doing a complex fraction, that means you're multiplying by the reciprocal. If you go ahead and do that, the 2's would cancel, giving you 1 over radical 3, which of course you would rationalize to be radical 3 over radical 3. Now, something I also want to point out here, there are only so many combinations that you can make given the 6 trig functions and given the values of the unit circle. So you are going to see a lot of these values start repeating, and that's fine. That's really kind of the whole point. So how about the tangent of 7 pi over 6? The tangent of 7 pi over 6, a tangent is a y over an x. We're going to need 7 pi over 6. So 7 pi over 6 is here. It's going to be the y over the x. So that is going to be equal to negative 1/2 over negative root 3 over 2. Again, another way you could possibly simplify this, so the negatives cancel. If they have the same denominator, those are also going to cancel. That's what the keep, change, flip would do. This essentially would give you 1 over radical 3, which is going to give you, again, radical 3 over 3. So you're going to see a lot of those values repeating. There's a reason for that. Again, it goes back to reference angles, reference triangles. If they have the same sine and cosine, they're obviously going to have the same tangent, cotangent, etc. Sometimes they differ just by a positive or negative, and that you'll kind of see as you go. So the secant of 11 pi over 6, a secant is 1 over a cosine, and in this case, it's 1 over x. So 1 over x, we need 11 pi over 6, so 11 pi over 6 is here. We're going to be looking at the x value, which is the square root of 3 over 2. So this is going to be 1 over the square root of 3 over 2. And just so you know, an easier way of doing 1 over really just means the reciprocal. So this is going to be 2 over radical 3, which you would then rationalize to be 2 radical 3 over 3. Cosecant of 4 pi over 2, a cosecant is 1 over sine, which means 1 over y. And hopefully you remember 4 pi over 2, that's really just 2 pi. And then the tangent, which is a y over x of 5 pi over 4. So starting with 2 pi. So 2 pi is over here. I'm going to have to do 1 over the y value, which means I'm going to do 1 over 0. If you think to yourself, well, 1 over 0, that's not going to work. And that's true. So it doesn't actually even matter what the tangent of 5 pi over 4 is. As long as I get some value that doesn't work, I'm going to go ahead and declare that this answer is undefined. So if you get a 0 in a denominator, that is always going to be undefined. Keep in mind, if you got a 0 in a numerator, then that would just be equal to 0, which would be fine. Go ahead and highlight these values for you. And then the only way that it gets harder, well, let's say that you have a value that isn't one of the unit circle values that we mentioned, but it is in relation. So take a look at negative 2 pi over 3, negative 5 pi over 2. If the given values, or let's say the given angles, are negative unit circle values, or unit circle values larger than 1 revolution, start by finding a coterminal angle. So again, these quick, easy ratios only work for things that are on the unit circle. So it has to be on the unit circle somehow, but if you either get a unit circle value that is negative, or you get one that is larger than 1 revolution, you have to make sure that you first start by finding a coterminal angle. So to start by finding a coterminal angle, negative 2 pi over 3, remember to find a coterminal angle in radians, you would be adding 2 pi, but that really means that you're adding 6 pi over 3. That's going to give you a value of 4 pi over 3, which means that the sine of negative 2 pi over 3 is equal to the sine of 4 pi over 3. So that means that I'm going to go ahead and find this value instead. So to find the sine of 4 pi over 3, you need a y value, and you need it from 4 pi over 3. So back to my unit circle, 4 pi over 3. I need the y value, which would be negative root 3 over 2. The tangent of negative 5 pi over 2, so you're going to take negative 5 pi over 2. You're going to add 2 pi, which would be 4 pi over 2. Unfortunately, that's still going to be negative, so I'm actually going to have to add 4 pi over 2 again. And if I do that, that is going to give me 3 pi over 2. So again, the tangent of 3 pi over 2 is going to be equal to the tangent of negative 5 pi over 2 because of the fact that they're coterminal, which means if I find the tangent of 3 pi over 2, it's the same answer. So I'm going to need a y over an x, and I'm going to need it from 3 pi over 2. So going back to 3 pi over 2, a y over an x, that would be negative 1 over 0. Alarm should be going off. Unfortunately, that is not possible, which means we're going to call it undefined. And then in the last one there, they kind of try to, switch it up a little bit. They put a negative 2 on the outside, and then they're also, both are going to need coterminal angles. So quite a bit of work to do here. So starting with negative 3 pi, I'm going to have to go ahead and add 2 pi. That's still going to be negative, so I'm going to actually have to add 2 pi again. So that is going to make this problem negative 2 times the cosine of pi. That's what would happen if I do negative 3 pi plus 2 pi plus 2 pi again. Then negative pi over 4, I'm going to add 2 pi to that, which means I'm really going to add 8 pi over 4, which means this is plus the cotangent of 7 pi over 4. So again, the reason why I'm doing that, you have to turn them into coterminal angles just to make the process easier to determine. A cosine is an x value. A cotangent is an x over a y. So I'm going to need to go back to my unit circle and then do those calculations. So starting with the negative 2, don't lose that. Going back to the unit circle, the cosine of pi, the cosine should be the x value. So that would be negative 1. So this is negative 2 times negative 1. Plus the cotangent of 7 pi over 4 means I need to go to 7 pi over 4. Oops. 7 pi over 4, sorry, it's getting a little bit crowded. So 7 pi over 4 is here. And I'm going to have to go ahead and find the cotangent, which means put the x over the y. So that is going to be 7 pi over 4. That is going to be the square root of 2 over 2 divided by negative square root of 2 over 2. Kind of go off to the side here. So starting with negative 2 times negative 1, that of course is going to give me a positive 2. The square root of 2 divided by negative square root of 2, well, if you have something, whether it's a fraction or not, divided by the same something, that of course cancels out to be just 1. And then because of the fact that it's a negative, it actually means it's going to cancel out to be a negative 1. And that's essentially just 2 minus 1, which turns out to be a 1. So this is kind of the crux of what it is you're trying to do here. You're trying to evaluate values of the unit circle. You need to use the ratio, you need to use the unit circle, and you need to be able to give a simplified calculation. In each of those problems, you were only asked to find one specific thing, but in this next question, you're going to be asked to find all of the ratios. So a little bit more going on here. So suppose that you have some angle theta that is between pi over 2 and 3 pi over 2, and the sine of which is equal to positive 1/2. So 2 pieces of information that's given here. So let's kind of think about the coordinate plane. The fact that they're telling you that the angle is between 3 pi over 2 and pi over 2, that essentially means that they're talking about the left-hand side here. If it's between pi over 2 and 3 pi over 2, it has to be somewhere on the left-hand side. Then, because of the fact that they're telling you that the sine is equal to 1/2, remember that a sine is a y value. You're only going to be able to find a y value that's positive in the second quadrant, which is how I know that I have to be looking for something in the second quadrant. So now that I've been able to identify the fact that quadrant 2 is where I'm looking, I'm going to go ahead and go back to my unit circle. If I'm looking at quadrant 2 only, and I'm looking for the spot where the sine is equal to positive 1/2, then that means that I have to be looking at 5 pi over 6. So going back here, again, each piece of information kind of narrows down the quadrants from 4 to 2 to 1. So the fact that you had to be between pi over 2 and 3 pi over 2, that's how I know that it was on the left side. Then the fact that the sign, which is a y value, is positive, that's how I know that it's quadrant 2. By looking at the unit circle, the only possible value that fits both of those requirements is 5 pi over 6. And 5 pi over 6, you're going to go ahead and copy the ordered pair, which is negative radical 3 over 2, comma 1/2. Notice that what the question was asking is they are asking you to find the other 5 trig functions. So that means in total, you want the sine, cosine, tangent, cotangent, cosecant, and secant. They already told you the sign, so that's why they're saying only find the rest. When doing problems like this, I usually find it best to make yourself, use the same pattern of values each time. So I'm going to start by saying the sine, and this is of 5 pi over 6, which they told me was positive 1/2. So that was a given, but I'm just going to write it again. Then I want to find the cosine of 5 pi over 6, and I want to find the tangent of 5 pi over 6. In order to do that, all I'm going to need is this ordered pair. So remember, a sine by definition on the unit circle is the y value, the cosine is the x value, the tangent is the y over the x value. So looking at that ordered pair, the x value is simply negative root 3 over 2. The tangent is the y over the x, so 1/2 over negative root 3 over 2. The 2's would cancel. Negative 1 over radical 3, which would become negative radical 3 over 3. So there's your sine, your cosine, and your tangent. And then next to it, I'm going to find the others. So with the sine, remember, goes the cosecant, then the secant, and the cotangent. Remember, each of these also has a ratio. So on the unit circle, this is 1 over y, 1 over x, and then x over y. Really, all you're doing is taking the answers from the previous 3 and simply taking their reciprocals. So if you want to find the cosecant of 5 pi over 6, take the sine, which was 1/2, flip it, and that's how you get a value of positive 2. To find the secant, you're going to take the cosine and then flip it. So that's going to give you 2 over negative root 3. You're going to multiply by root 3, which is going to give you negative 2 root 3 over 3. Finally, for the cotangent means you're going to flip. It's easier if you flip before you rationalize. So negative 1 over radical 3, if you flip that, you're simply going to get negative radical 3. So here's the sine, which again was given. Here's the cosine, and here's the tangent. Again, that seems to always be my order of preference, just in terms of how you find them, to make sure you're always finding the reciprocals next to each other. Cosecant of positive 2, secant of negative 2 root 3 over 3, and then a cotangent of negative radical 3. All right, for these last 3 problems, let's take a look at what it's asking us to do. So describe below our angles in standard position. Determine in which quadrant or on what axis each angle terminates. Give an explanation that clearly justifies your reasoning, and if no angle exists, explain why. So there's a couple of things I want to just kind of flesh out here before we actually go ahead and apply them. So I'll just kind of scroll over here. This would be what I would essentially call name that quadrant. So name that quadrant, or let's say name that quadrant or axis. That's what it's asking you to do. Each piece of information, again, narrows down your choices. If you're talking about the 4 quadrants, each piece of information cuts it in half from 4 to 2 choices, and then ultimately from 2 to 1 choices. So name that quadrant or name that axis. Is it a positive x-axis, a positive y-axis, or a negative x or y-axis? The most important thing that I want to point out here is that it does not say unit circle. Because of the fact that it does not say unit circle, we do not know that the radius is 1. So it does not say unit circle, so we do not know that the radius is 1. So let's kind of put that together. Does not say unit circle, so the radius may not be 1, but there's good news. It is always positive. How could you possibly make a circle where you had a negative radius? That does not make sense. There would be no circle. So if you are not on the unit circle, which in this case we do not know if we are or not, that means you cannot assume that the radius is 1, but no matter what, whether you're on or off the unit circle, you can always assume that it's positive. So that's the good news. So keeping that in mind, let's go ahead and take a look here at example A. So they're telling us that the cosine of theta is greater than 0, and then they're telling us that the tangent is less than 0, and they're either asking us to tell us what quadrant or what axis. So the cosine of theta being greater than 0, remember that we are not necessarily on the unit circle. So in terms of the ratio, we have to assume that we're on a circle of any radius, which means we have to use the more general definition, which is x over r. Remember, we can't assume that r is 1. And they're telling us that this is greater than 0. So if the cosine of theta equals x over r is greater than 0, and r is positive, then x must be positive, and the angle is to the right of the y-axis. So again, if you're thinking about the 4 quadrants, the fact that a cosine is an x over an r, the fact that an r is always positive, the only way that you could divide something by a positive and still get a positive would be if x is positive. The only way that x can be positive is if you're to the right of the y-axis. So that means we have narrowed our answer down to somewhere over here in the blue. Now we have to take the second piece of information, and the second piece of information is that the tangent of theta is less than 0. So keeping that in mind, because of the fact that a tangent is equal to a y over an x, and because of the fact that it has to be less than 0, we already figured out that x is greater than 0. We did that in the previous step. So if y over x is less than 0 and x is already positive, then y has to be negative. Which means if I go back to my choices, because I had already determined that I had to be to the right of the y-axis, because now I know that y has to be negative, that's how I know that I have to be in quadrant 4. So again, just to summarize that, then y is less than 0, and theta terminates in quadrant 4. So kind of a lot going on there. Here it's asking you to explain and justify. Remember, that's setting us up for those free response questions. You could essentially come to the same conclusion without writing all the words, but it is important that if you needed to give an explanation, that you could. So let's try that again with example B. So the cosine of theta is greater than 0, and the tangent of theta is undefined. So again, 2 pieces of information, each of which is going to narrow down our choices of either quadrant or axis. So 4 potential places to start. And the first thing that they're telling us is that the cosine of theta is greater than 0. Remember, we do not know if we are on the unit circle or not. So if the cosine of theta, which is equal to x over r, is greater than 0, and r is positive, remember r is always positive, then x has to be greater than 0 and to the right of the y-axis. So very similar explanation as it was in the previous problem. If you're dividing something by something and getting a positive, if the denominator is positive, the only way that that can happen is if the x value is also positive, which means we are looking somewhere over here. The second piece of information is the fact that the tangent of theta is undefined. So that's going to tell us something else. So if the tangent of theta, which equals y over x, is undefined, the only way that that can happen is if the denominator is equal to 0. So we're going to have to look in the shaded pink region, and we're going to have to be able to find some value where the x is equal to 0. And it turns out that that is actually not going to be the case. There is no value on the right side of the graph there that is going to have an x value of 0. There is a location where the y value is 0. Remember, if you were over here, this would be 1, 0. But because of the fact that the x is talking about the length of the radius that's turning, it's not possible. So that's what we're going to go ahead and say. So if the tangent of theta equals y over x is undefined, then x equals 0. Since x cannot equal 0 under these conditions, no angle theta exists. So sad but true. Let's go ahead and do the final one here. And again, sorry, that should be C instead of D, but hopefully no big deal. C instead of D. So again, 2 pieces of information, each of which is going to help you take, narrow down your information. So starting with the fact that the sine of theta is less than 0. So the sine of theta in general is equal to y over r. And remember, r is always positive. Then for the first time today, y has to be negative. The only way you can divide something by a positive and be less than 0 is if the y value is negative. So if the r is positive, but the y is negative, then that means that we need to be underneath we need to be below the x-axis. So that means that we are going to have to be somewhere here. The second piece of information is the fact that the secant of theta is undefined. So the fact that the secant of theta is undefined, remember what the ratio for a secant is. So a secant is equal to r over x. Then x has to be equal to 0. Are there any locations in that purple where x is equal to 0? Turns out that there actually is a location. It would have to be here. Remember, this is the point 0, -1. So the angle must terminate on the negative y-axis. So again, a little game of what I call name that quadrant, or essentially in this case, it's name that quadrantal. Remember, you kind of had a similar scenario happening in B and C. In both cases, you knew that a value was undefined. In example C, there was a value that existed that met those conditions. In example B, there was no value that existed that met those conditions, which is why we had to say that no angle existed. So there's still a lot more to come in terms of trig. How do you take the first part of the lesson and kind of add it together with the second part of the lesson? There's still so much more to come, but for now, you are fully equipped to go ahead and try homework number 43. So thanks very much for tuning in, guys, and we will catch you next time.